Hello, this is CPT class, Section 3, Team 4 presenter Park Jong-tae. I will proceed with this presentation in this order. This video is the overall look of our product. The target of our product is people with disabilities. Products for disabled have already been developed, and socially, there are also many legal arrangements for these people. However, as a result of the investigation, it seems that there is no application for them in home that spends the most time. So we want to relieve their discomfort through this product. As you can see, it was designed to include a driving unit with 3 degrees of freedom in front of the existing drawer. As you saw earlier, I will explain the x-axis mechanism first. The rack and pinion mechanism is adopted. As calculated results, the required speed and required torque are 108 RPM and 15 km/cm. So the rated speed and rated torque of our motor is suitable for 127 RPM and 16 kg/cm. Here the required speed is calculated considering the driving time set by us. Next is the y-axis mechanism. Power was transmitted using bevel gears and lead screws. As the calculated results, the required speed and required torque are 600 RPM and 8.6 kg/cm. So the related speed and related torque of our motor is suitable for 766 RPM and 25 kg/cm. Lastly, the jet-axis mechanism. The rack and pinion mechanism is adopted, and as the calculated result, the required speed and required torque are 57 RPM and 1 kg/cm. So the rated speed and rated torque of our motor is suitable for 66 RPM and 2 kg/cm. This is the name and price list of the parts mentioned above. The specific part here is the sound absorber, typed in red. In order to silence, it was adopted despite the above price. Compared to the existing built-in cabinet without the automatic system, it was judged to be quite reasonable and reduced by 10% due to mass production. It was priced at roughly 1,318,000 won. The next is ANSYS analysis. The mesh of each important part is as follows. Due to the limitations of computer performance, an error occurred when attempting to mesh more than that size. The following are pictures that gave force and velocity. The floor is used as fixed support and the momentum RPM values corresponding to the maximum specifications of our motor that are given. And the force is applied assuming the cell weight is 20 kg. The following is the static analysis result without speed applied. The maximum deformation is 0.06 mm, which is deformed at the end of the jet-axis driving part. But in our rail structure, it can be supported, so it is judged to be smaller than 0.06 mm. The following is the result of stress analysis. The biggest stress occurred inside the small gear of jet chassis. The value was 51 megapascal, so it was judged to be safe because it was smaller than the material's yield stress of 370 megapascal. Next is the analysis result in the driving situation. The maximum deformation was almost the same as before with 0.06 millimeter. The maximum stress was 48 megapascal, which decreased compared to when the force was applied in stationary state. This is the result of the driving simulation based on the engineering design and ANSYS analysis that I mentioned earlier. We realized that the material properties of parts, gravity, friction, etc., and put our motor speed and torque as input. As with the analysis results, it was confirmed that it operates stably. This is our future works. Thank you for listening.